Hello everyone. Today we'll be solving the problem number 238, product of array except self, right? So you can just completely read the question and also try to understand the question with the example. So I'll just summarize the question for you so that it will be easier to understand, right? So what the question states here, we are given an array nums. You can clearly see here, we are given an array nums. We need to return an array answer. This one, we need to return an array answer such that each element answer of I is the product of all elements in nums except nums of I, iterated value of the nums. While I say this, we can clearly see here nums they have given, they have considered here 1 2 3 4. So while we consider 1, we have to exclude 1 and multiply these three elements. Actually this will give us 4 into 3 nothing but 12, 12 into 2 24. So we have to do the same thing for all the elements. Next thing is we have to exclude 2 and we have to multiply 1 3 and 4, nothing but 4 into 3 12, 12 into 1 is nothing but 12. Same thing for 3, we have to exclude 3 and we have to multiply 1 into 2 into 4, nothing but 8. Finally we'll be excluding the 4, we'll be multiplying 1 into 2 into 3, nothing but 6. So same thing for the this example as well. While we exclude 1, so we have 0 here. Until we exclude 0, except for this one, everything will be 0 itself. Anything multiplied by 0 is 0 itself. While we exclude 0, here this will be minus 1 into 1, nothing but minus 1, and minus 3 into 3 is nothing but minus 9. Minus 9 into minus 1 is nothing but plus 9. For all the other elements, it will be 0 itself, right? So yeah, I hope this is clear. So let's see. Let's first understand the question. So what are the key important points here? So they have given the solution must run in big O of n time. So they have clearly mentioned the solution must run in big O of n time and division is not allowed. They have clearly mentioned division is not allowed and the product of any prefix or suffix of the numbers will fit in 32-bit integer. So that's what they have given here. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. So I hope the question is completely clear. So initially what we'll do, we'll discuss all the edge cases, then we will be discussing about the approach, and after discussing the approach, let's write the code and discuss the time and space complexity, right? So initially let's discuss all the edge cases. So I'll just come here, just give me a second here. So the first one, let's go with the single 0 in the array. So the input will be, I'll just give here 1 0 3, nothing but we are going with a single 0 in the array, right? So the output must be here, when we exclude 1, 3 into 0 is nothing but 0, and when we exclude 0, 1 into 3 is nothing but 3. When we exclude 3, 1 into 0 is nothing but 0 here. So this is for the single 0 in array. So this is the first edge case that we are going with. So next, let's move on with the next edge case, all zeros in the array. So I'll just come here. While I say all zeros in array, I'll just take the input 0 0, right? So the output has to be 0. So when we include, when we exclude any number is multiplied by 0 is 0 itself. We have all zeros, so the output will be 0 itself, right? So this is for all zeros in array. So I hope the second edge case is clear. So next one, let's move on with the array with negative numbers. So I'll just come here. So I'll just give here, let me consider the input -1, 2, -3 and 4, right? So the output has to be, first let's exclude 1. This will be 2 into -3, nothing but -6. 6 into 4 is nothing but -24. So let's exclude 2. -1 into -3, 3. 3 into 4 is nothing but 12 here. Same thing let's do for the other numbers. It will be -8 as well as 6, right? Sorry. So this will be the output. So this is for array with negative numbers. Just give me a second here. Yeah, array with negative numbers. The final edge case will be, we will go with the array with same elements. While I say array with same elements, let me consider the input, this one, 2. So here the output will be, when we exclude 2, we'll multiply 2 into 2 into 2, right? This will be 8. Same, we'll get 8 for every number, right? So when we exclude 2, same thing we are multiplying with 2. This time this 2, this 2 and this 2. We'll get 8. Same thing goes with the other 2 numbers as well. So the output will be 4 8s, right? So this is array with same elements. This is for the array with same elements. So let's see what are the edge cases that we saw. First one was for single zero in array. We can clearly see here. The second one was for all zeros in the array. We can see here. And the third one was for array with the negative integers. We can clearly see here. The fourth one is array with the same elements. We can clearly see here, right? So these are the edge cases that we need to keep in mind. Next, let's discuss about the approach and start writing the code. I'll just explain while writing the code itself. So here the approach that we'll be going with here is map based prefix suffix multiplication, right? So first what we will do, we will compute the left products. So let's compute the left products first. So next we will be computing the right product. So I'll just come here, I'll just give, we will compute the right products. Finally, we will calculate the result. So this is the approach that we are going with. So I'll just give here approach. So this is nothing but map based prefix suffix multiplication. So this is the approach that we'll be going with. While I say compute left products, compute right products and calculate result, let's see the same thing while we write the code. So I'll just delete this one. So I'll just come here. Initially what I'll do, let's go with the let's initialize the, or let's initialize the length of the input array, the en. I'll just give here nums dot length. As I have said, we'll be going with the map based prefix suffix multiplication, right? So we'll be making use of the map to store the left and right products. How can I write that? I'll just consider left products here. Let me initialize this one to the new map. So this is simple, right? Let me copy the same thing here for the right map as well. So why this is lagging? So instead of left, I'll just consider here right. So what we have done here, we have made use of the map to store the left and right products. The next step is we will initialize the array to store the final result. So we need the array to store the final result, right? So we'll be initializing the array to store the final result. So I'll just come here. Let me make use of the variable result. Just give here new array of length n, right? This is fine. So what we have done here, we have initialized n to the length of the input array. Next we have created the a map to store the left and right products. Finally, we have initialized the array to store the final result. So as we had discussed in the first this one in the approach previously, so the first step will be going here as computing the left products. Then we'll go with the computing the right products. Finally, we have to compute the result, right? Let's see how to compute the left products first. So I'll just give here left products. We are what we are doing here, we are computing the left product. So I'll just give here left products dot set here 0 and 1. So this is nothing but the base case. So here no elements to the left of the first index. So again I'm telling this is the base case. So here we have no elements to the left of the first index. So let's go with the iteration here. For we'll start with the 1 I plus plus. Let's increment this one. Next, let's go with left products dot set I comma. So I'll just copy the same thing here. Left products. We have to get the value, right? So to get the value, I'll just make use of get I minus 1 previous value. So I'll just go with I minus 1 into nums of I minus 1 within the array. So what we are doing here, for each index, left products is the product of all the elements to the left here. This one, this line, whatever I have written. So for each index, left product is the product of all elements to the left. So if you are not understanding, so please do dry run the code. You will understand it very clearly. So I'll just come out of this loop. So just give me a second here. So this is it for computing the left product. So next step was to compute the right products in the approach, right? So let's compute the right products now. I'll just go with right products dot set. Will consider n minus 1 and 1. So this is the base case here. So what we are doing here mainly, so we are making sure that no elements are to the right of the last index. Here for the left, whatever we have written here, left products dot set of 0, 1, whatever we have written, that was the base case for the computing the left product. So we made sure that no elements were to the left of the first index. Here while computing the right products, this is the base case, we are making sure that no elements are to the right of the last index, right? So let's start the iteration. So I'll just come here, let me give for let n equals n minus 2 I'll consider reverse iteration, right? I greater than or equal to 0, and let me decrement here. Why? Because we are making sure that no elements to the right of the last index. That was the base case, whatever we have considered here. So we are performing the reverse iteration here. I'll just give here right products dot set comma right products. Let me make use of the get here I plus 1 finally into nums of I plus 1. This is fair. So what we are doing here, for each index, right product is the product of all elements to the right. Here in the left, this line here, for each index, we made sure that the left product is the product of all elements to the left. Here, what we are doing here, this is simple. And so I minus 1 we took. Here we are considering I plus 1. What we are doing here, for each index, right product is the product of all elements to the right. So I hope this is clear. This is similar, right? Very similar. Just the main difference is here the base case. So we are making sure that no elements to the left of the first index in the left products. This one, sorry. Here base case, we are making sure that no elements to the right of the last index, right? So after computing the right product, let's come to the last step. Nothing but we have to compute the result as we had discussed in the approach. I'll just come here. I'll give for let I equals 0, I less than n, I plus plus. This is fine. Finally, I'll just give here iterated value of the result is nothing but left products. I'll just copy this one, paste it over here, dot get of I and into right products. Let me copy this one, right products. We have to get the values of the left products and the right products, iterated value of the left products and the right products. As we are making use of the hash map, so I'll just make use of the get here. So let me give here I. This is fine. So we are just multiplying the left and right products for each index here in this line, result iterated value of the index. What we are doing here in this line, we are multiplying the left and right products for each index. So if you are still not understanding, please do dry run the code. You will understand this one very clearly. So I'll just come here. Finally, let me give return result here. So we are just returning the final result array, right? So this is it. Let me format this once and let me run the code. So here unexpected token minus we are getting. So yeah, I have to initialize I equals n minus 2, right? The line number 13. So I just come here. So I have given here I equals n minus 2. This is fine. So yeah, let me run the code again. So right products is not defined. Where line number 12. Just give me a second here. So yeah, what we have initialized this one, right products line number. Oh yeah, this one has to be capital P. This is fine. Let me hit the submit. So still we are getting the error. So right products in line number 18 here also we have to give capital P, right? So let me hit the run button. So yeah, now the sample test cases are getting passed. Let me hit the submit now. So we can clearly see the code works absolutely correct here. So So I hope this is completely clear, whatever we have written. So let's go with the, let's discuss about the time complexity and the space complexity, right? So the approach name that we went with is map based prefix suffix multiplication. We know that. So the time complexity here is big O of n. So why the time complexity here is big O of n? Because each step involves single loop through the array. So we can clearly see each step involves single loop through the array. So we can clearly see here. So the overall time complexity would be big O of n. Then what would be the overall space complexity? The overall space complexity would be big O of n as well. So why the space complexity is big O of n? Because two map objects are used to store left and right products. Again, I'm telling two map objects. This one are used to store left and right products, right? This one. Two map objects are used to store left and right objects. So the overall space complexity would be big of n as well. Let me write the same thing over here just for my reference. Overall time complexity would be big of n and overall space complexity would be big of n as well. So I hope this is completely clear. So this is it. Thanks for watching, guys.